by dt equals 2x plus 6y. dy by dt equals 3x minus 5y. That is the acceleration in the x direction is a function of the x and y coordinates, and the acceleration in the y direction is a function of the xy coordinates. The above differential equation could be written in the matrix form as d by dt into column matrix x y equals square matrix 2 6 3 minus 5 into column matrix xy. And to solve the above equation, you construct the determinant 2 minus alpha 6 3 minus 5 minus alpha equals 0 and set out to solve for alpha. Whereas we get the equation that will be soon on the screen, that is, solve it yourself from the determinant 2 minus alpha into minus 5 minus alpha, yes, here it is, minus 18 equals 0. Whereas we get the equation alpha squared plus 3 alpha minus 28. And solving this simple second degree equation, we get that alpha, the two roots alpha 1 equals 4 and alpha 2 equals minus 7. Let's call that 1. And the alpha 1 and alpha 2 are called the eigenvalues. And substituting for each one of the roots one at a time into the relation C minus alpha 1i row matrix into column matrix x11 x21 equals 0. Of course, C minus alpha 1i is called is a left hand factor of 0, and x11 x21 are called eigenvectors. Multiplying is forming the second equation, C minus alpha 2i into column matrix x12 x22 equals 0. Let's call that equation 3. And substituting in 1, that's the root 4, we get matrix 2 minus 4 6 3 and minus 5 minus 4 into column matrix x11 x21 equals 0. And from this first relation we get the equation minus 2 into x11 plus 6 into x21 equals 0. From this last relation we can put this last relation into the matrix form x11 x21 equals column matrix 3 over 1. And similarly, substituting 2, we can have the matrix 2 plus 7 6 3 minus 5 minus 7 into column matrix x12 x22 equals 0. We get the relation 9x12 plus 6x22 equals 0, from which we can form the matrix equality column matrix x12 x22 equals column matrix minus 2 3. Let's call that double I. From 1 I and double I, we can write final relation x equals 3a times e to the power 3t minus 2b into e to the power minus 7t. Y equals a into e to the power 4t plus 3b times e to the power minus 7t. Whereas where a and b are constant to be obtained from boundary conditions. Now let's here put our initial conditions to be able to solve for a, the values for a and b. Our initial conditions are at t equals 0, x equals 5 and y equals 9. And solving these two equations simultaneously, we have 5 equals 3a minus 2b and 9 equals a plus 3b, where we get that a equals 2 and b equals 3. Note that whatever the value initial condition values, we get different a's and b's, but the original values of our equation remains unaltered. That are 3 times a, whatever it is, into e to the power 4t minus 2 times b, whatever the value of it, to the power minus 7t. That is 3 and 4t minus 2 and 7t remains unaltered. The same a, 4t for y, and 3 minus 7t for Why?